Our first speaker, I should point out, again, please make sure your cell phones are turned off. And if you can fill out your session evaluations immediately after the session to help us in the future conferences, we would appreciate that. Our first speaker is Antonio Skarmeta from the Universidad de Murcia in Spain. He's got a rather interesting background, which is outlined in the conference profile. He has PhDs in computer science, and he's been with the university since 1993. He works in the areas of distributed artificial intelligence, telelearning, computer support for collaborative work, and distance and open learning. And currently involved in, as well, the Euro 6 project, and has also written numerous papers. Antonio, the floor is yours.
Okay, thanks. Okay. Okay. First of all, thanks for all of you coming here, and I hope you have a better trip than mine. Because we were I think since Saturday we are trying to arrive to Limerick. My presentation, in this case, has a generic name, a new security service based on PKI. Basically, the idea will be to show different kind of services we are now trying to implement in base of our development in our PKI that we have since several years ago. I think it was in Lund in 3 years, or maybe 3 or 4 years ago, that we present in this, also in the Terena conference, our first PKI development for the University of Murcia. University of Murcia has been, I think, in Spain, one of the pioneer university in implementing a complete PKI, and also a development that all, with every different service all around this PKI, basically using smart cards. As we will see, what we have done since then is improve, evolve our own PKI in order to implement new kind of services, and two of them I will try to present here today. Basically, the presentation will be organized, as you can see here, with just an introduction in order to show you which are these new services. Then we will make a shortly presentation of our last, I can see, development in our PKI that is porting to IPv6 in the context of Euro 6 project, and also tomorrow in the workshop we will extend more about what is done here. And then we will show you the two kind of services we are now implementing and working with with our PKI, that is distribute security policy management and also distribute credential management system. And finally we will conclude with some ideas and also a new ideas about development that we are on work now. Basically, as you all know, PKIs are a central element of different security services. In our particular case, since we start with the university and in the university framework, we have used our PKI basically for support security and service for the students and also for professors, in the teachers and in our own university. And actually what we are trying also is to extend its services to other regional governments, for example, in our region that is involved in an active project for development, digital certificate for all the citizens and so on. So basically in different environments, actually PKIs are a central topic, and in our case what we have been done is to trying to, starting from our initial development, to try to improve this, trying to include new services and actually think about how we can use the PKI in different kind of environment. Basically, as we will show here, we are very interested in this moment in two different areas. One is the use of the PKI in order to manage the security policy in a distributed environment. So the idea is to have the possibility to define rules that govern, in some sense, certain behavior of device, and use these rules and then try to put it in a service and be able to recover them in order to modify the behavior in a dynamic way to different device. Basically, we will, as we will show then, we have sent our focus actually is basically in security policies, but also it can be extended to another kind of policies. The other service we are also working with is the use or the extent of our PKI in order to manage a different kind of certificates in some sense. Not only identity certificate, but also certificate that give us authority certifications and give us, for example, role management basically in the idea of the SPKI infrastructure. So these are basically the two lines where starting from our PKI and starting with the service we have with our PKI, what we try is to evolve in some way and extend the service actually we are offering. Also, as also I have indicated, our PKI actually has been ported to IPv6, as you can see here, in the context of the Euro 6 project. It's one of the IST project that is concerned about the deployment of IPv6 in Europe, in this case. And as we will show also maybe tomorrow in the workshop, it is going to be used not only by our project, but also for other projects, in this case for 6net, because our collaboration with UCLs and also University of Southampton, in order to test and see how our PKI can also serve as a basis for another kind of service in the IPv6 framework. So this is generally the idea, the motivation in some sense. In our cases, we consider that our PKI actually is enough mature in some sense in order to be useful in different environments. And what we are trying is to define and to check its use in a new kind of service as the one we propose here. First of all, let's just give you a short snapshot about which is our PKI actually. Although we call it IPv6 PKI, really it is actually either for IPv6 and also for IPv4. It's just that because the last development is the porting to this new protocol. Basically, what is significant in our PKI is that it is, first of all, it's fully developed in Java, so it's, in that sense, it's multi-platform, and it can be used, and actually it's being tested with different kind of end systems. It has fully support for different kind of service. The typical one, user, renewal, revoke certificates in the context of the PKI. It has obviously implement all the different entities, registering authority, certification authority, and so on. Also, you can access it in order to get your certificate either by the ARR or maybe using the web browser. It has full support of LDAP directory, where it is store all the certificates. And something that was important since its initial development is that it has fully support of smart cards. This was an important topic initially in our PKI because we work with high relation with the saving banks in our own region. That is the one that is in some sense supporting part of the development, because in this case all the students of our university have a smart card given by this saving entity. So the idea was to use the smart card as a support in this case for the private case, the users, and also to give another kind of information about the user, that they can use this smart card just to go to the library and maybe to make some payments using micropayment protocols. Actually, we have, in the case of the smart card, as you will see also in another picture, it is used not only the classical RSA, but also we have development in Java cards, and we have an extensive, I think, support for different kind of smart cards, and I think this is one of the important things also that give us more security to our own framework. Also, as we will show next, we have fully support for PKI certification policies, and actually also we give support to VPN-based certification support using SEP protocol, and also OSCP protocol and timestamp protocols. All the system you can administer the system using a web browser, and obviously in that case either the administrator, either different security activity in the PKI are also support using smart cards and so on. So as you can see here, we have, in some sense, a PKI with complete range of service, with fully support of different elements, not only just to make the classical extension of the certificate, but also, for example, for support for VPNs, also full support for a new kind of services using OSCP protocol, for example. So the idea is, once we have this, what we want is to try to check how we can use this PKI in order to analyze its useful in different kind of new services, as we consider that are important in the framework, not only of the university, but also in framework of services that are needed in different contexts, as we will see next. No? One important thing I also have indicated, it is not just the development of the University of Murcia. It's actually being also tested, and also there is a great collaboration with another university in the context of different projects in order to have something that it's useful for in different contexts and for different projects. So in that sense, I think that Diego Lopez also from Redidis, he wanted to make us a presentation on Sundays Terena Task Force about the PKI in order maybe to another university also to collaborate and participate and check and test it in the context of different projects. So the idea is we have this, and now we can use it for support new kind of services. Here you can see that it's a general picture of the different components I have just talked about. As you can see in all of them, the idea of the smart cards is continuous use in the different components of the systems. Obviously, this use of smart card is not mandatory. You can use it or not use, but we have, as I say, a fully support of it in the different components of our systems. Here you have the URL where you can find it only in the new IPv6 version of our PKI. So, starting from this, I said what we want is to check it's in using in different kind of services. The first one I think is maybe and one of the most interesting one, because it's really can be useful in different contexts, is the distributed security policy management architecture we have defined. It's called DSPM. Basically, it's what we want here basically is to be able to define, in this case, rules that indicate how will be the behavior of different devices or different entities in the network. In the idea of a distributed framework where what we want is to have the possibility to change in some sense, in a dynamic way, the behavior of different components. What we are trying here is not just our own work. I think it's many people also from internet, different internet task force. They are working in order to how to implement the possibility, how to have the possibility to implement this policy-based networking capabilities in different devices. Basically, a policy is not more than a rule in some way that defines what to do when certain conditions appear either in the network, either in certain device, which are the actions that are going to be taken. Obviously, as in particular in our case, we are going to focus in security policies that are going to be applied in the context of a security environment. And obviously, in all this case, the need of a PKI, something that allow us to indicate that the policy is legal and also it's secure, it's fundamental. And this is why, obviously, every policy must be signed by someone that can be able to introduce this security policy in this way. Actually, we will show you the use of this policy management in two contexts, either in the PKI behavior itself, and also in order to implement VPNs. In the case of the application of security policy for PKI, basically what we have is the possibility to define the way the PKI is going to work itself. In some sense, what is going to happen in some way when we are going to define, or when someone requests, for example, some certificates, which, for example, will be the validation time, or for example, in the case of renewals, which will be the rules that will govern the renewals of the certificate, or for example, the revocation. These are the three kind of categories, the general kind of categories of rules we can work with in order to define the behavior of the PKI in different contexts of the system. Basically, what we are defining is what we have in this case is a digital implementation of what is the certification practice statement, the CPS. We implement it in the digital way and we sign it. Someone that is able to do it and is going to sign it. Normally the CA, there are another alternative, but it's logical, the CA, the one that's going to sign it. So in that way, we know that these policies, these rules that are governing the PKI are valid in the sense because some entity, in this case the CA, has defined it as the central component. The important thing here is that although we make a centralized definition of the rules, they are going to be applied in a distributed way because the different components, either the registration authority or the different components of the PKI are going to recover the rules and are going to apply, in this case, the actions that are indicating the condition of the different kinds of rules. In that way, we have certainly a dynamic behavior of the system depend on the condition that you can change in every moment during the lifetime of the PKI. Basically, in order to do that, for example, here we have just a snapshot, for example, of one of the tools we have in order to implement, for example, or where the renewal validation of the certification is done from accessing the information about the rules that govern this renewal activity and implementing in that way using this component that is using the policy in order to check if he can do it and up to when he can renew this certificate for the specific user. So in that way, as you say, as I have indicated, we have a dynamic behavior of the system in every moment based on a centralized repository where we have the information and where the different components just go recover and use it in order to manage its behavior. The other kind of, for example, frameworks where we can use the security policies, for example, is in the implementation of the VPNs. You know, VPNs actually different either device or different components in a distributed environment are using, for example, VPNs using IPsec in order to try to cipher or try to make secure a communication between this entity. The problem here is normally this is done in a manually or ad hoc manner in some sense. So the idea to have a way to do it in a dynamic way and also in a controller in some sense way is really important. Here, what we are trying to do is to have, or what we are having actually, because it's being tested also actually in the context of these two projects I have just indicated, it's the implementation of a policy-based networking management system, what we call it PBANM. Where basically we have, in this PBAMN, we have two basic components. What is the process definition process, the policy definition process, and the policy recovering process. The idea is these two components of our system will let us, in one case, to make the definition of which will be the rules that govern for example, the VPN creation or the VPN definition, and the other one will be the specific entity that will participate in the recovery of these rules and the implementation and enforcement of them in the different components of our system. In the case of the policy definition process, basically what we have is a collection of rules that indicate us that depending on certain conditions, for example, depending on, for example, the type of traffic, depending on, for example, the port that are being used in a certain communication, then some action will be taken. For example, certain level of authentication, or maybe the encryption of the traffic that is going down in that moment. So in order to do that, so we need to define these rules. These rules that will be the one that govern when, for example, a VPN is a start or is defined between two different entities. So in order to do that, what we have done is to define using a language in the sense that is independent of any platform. In this case, we use the SIM model and we implement it using XML. We define the rules that are going to, that characterize in this case this policy. And then what we have is maybe in the case of XML, it's easy because using style sheets, for example, we can translate them to a specific IPsec and IKA implementation and check that this kind of things work. So the idea of, in this case, of using a generic way of definition of the rules, so and also to have an independent syntactic and semantic characterization, and then a way to enforce these components, to separate in some way the definition from the enforcement, let us be able to make an independent in this system that then, depending on the specific device that we are going to implement it, we have to make the specific translation depending on of its characteristics. So here you can see, for example, the behavior in the definition of the policy, where we have an administrator. Obviously, all of these activities are secure. So we use, obviously, in this case, the PKI is the basic in order to make all these activities secure. And also, in this case, we can use, for example, in the case of the SIM client, we can have smart cards in order to have improve the security of the system and so on. So basically, what we have here is that the client connect with the policy management, in this case, that is the element that is going to analyze and validate the rules that are defined by the administrator, and also are going to parse, in this case, the object that are exchanged using SIM. And once it is validated and signed, obviously, by the administrator, it's going to be stored, in this case, in a repository, in this case, the LDAP, the same repository also that we are using in our case for storing the certificates. And in that moment, this policy is able for any device to recover it, as we will see now, using another components. This second part, the recovery and the enforcement of the policy, it is done using two different entities, what we call a policy decision points and the policy enforcement points. Basically, they interact, these different components interact also using a standard, in this case defined by the ETF, that is the COPS, the Common Open Policy Service. It's a way to, how these different components are going to exchange and ask, in this case, the different, what the kind of rules they are trying to recover. And basically the idea is that, as maybe it's better with that picture, here you can see the general interaction we can have between the different components. Here you have the LDAP directory, where it is stored, in this case, the policy. The PDP is the one that's going to manage, in some sense, the request for the different entities, and it's going to retrieve it and interact with the specific enforcement point. And the enforcement point, the policy enforcement point, are the ones that are going to have different implementation, depend on if the device directly can understand the COPS message, or if not, maybe because we have an interaction using SNMP, for example, for a router, in this case. This is the kind of, for example, of test we are doing in our implementation with, for example, UCL, or maybe because there's some way to translate these rules to a specific operatories or commands that are needed for another device. So in that way, we have a standard way to get the rules, and in some cases, a standard way to enforce them, or in another way, we need a specific translator for the different kind of device. But in that way, in all these contexts, we have a generic way to define the rules, to define the policies, to recover them, and maybe in that way we can have a dynamic behavior, or we can make that the device behave in a different way depending on the condition of the network, so maybe the condition of the administrator. The administrator is going to consider for his network in this case. No? The other kind of service also we are thinking about, that we are also implementing in our PKI, is a rather radical different kind of service. It's radical in the sense that it's not directly related with the previous one, but also obviously it is based in the use of the PKI as support of all the system, and also in the use of the certifications or the certificates in order to implement different kind of service. In this case, it's the extent of our PKI in order to manage credentials and authorizations and the future also roles. Basically, the idea here is, what is the motivation of including this new service in our PKI is to extend the use of certificates, not only with the classical one that are the identity certificates, but also, for example, certificates that give us information about group membership, and also that give us credentials or authorization for access to certain kind of device, for example. Actually, we are using it, for example, for different devices that help us, for example, in order to gain access to the rooms or to certain kind of specific service. What is important here is to show to the device, in this case, think about the door, for example, to show to the door, in this case, present him a certificate that you are a member of certain groups. And because you are a member of certain group, maybe, for example, professor of the Faculty of Computer Science of the University of Murcia, you can open a specific door during weekends, for example. So, in that way, the idea is to extend, or obviously, these kind of things you can do it with more or less complex using this classical certificate. But the idea of using the credential of the authorization is some way simplify and give it more flexibility in order to manage this kind of specific situations. So basically, what we are doing here is to extend our PKI in order to support SPKI, simple PKI services. In this case, to give group support and also to the credential and authorization. Basically, what we have here, actually, for example, is really our system is composed of two different parts. Because one is going to manage the SPKI identity certificates that are really naming certificates, in order the classical ones, and also and this part is the NMS, the naming management system, and also we have the AMS, that is the attribute management system, that is the specific part that take care about the authorization and attribute certificates, the one that for example, going to give to a specific group, for example, access to a specific resource. In that case. In order to implement all of this, we also have defined a protocol that is AMBER. It's an extension in some sense of SSL in order to facilitate the negotiation of different, for example, conditions or different kind of, or the specific case of certificates that are going to have between the different entities, for example. Sorry. In the case of the NMS, the naming management system, as I indicate, basically the kind of certificate it's going to manage is the one that link a specific name to a particular, for example, public key, or the possibility of defining the group membership. Basically here, a central point will be the naming authority, that is the authority that is going to grant a specific access and using using SPKI SEL is going to define if certain user, when he presents a certain certificate, he is able to, for example, be a member of another kind of group. You can see here more or less the structure of the system here. So we have a requester, that is the one that is asking for a new certificate. Maybe also he's presenting another kind of certificates, for example, showing that he is a professor of University of Murcia, in this case. And once you receive this request, the requester access directly to the naming system, or using what we call a service access point in order to check if it is possible to give him this new kind of certificate. Basically, the idea of the service access point is an abstraction that maybe in some case it is interesting not to the requester to know exactly which is the naming authority, for example, because we want to protect this naming authority, or maybe because he don't know which of the different naming authority we can have in a specific environment is going to give him the certificate. So in that way, the requester goes through the service access point, and the service access point is the one that redirects his request to the concrete naming authority system. The naming authority basically is the one that controls the policies about the authorization. It's the one that, using an SPKI ACL, is going to check if he is able to give or not the certificate to this user. And basically, he receives as input the request, in this case, of certificates, and also he generates the new certificate according to the rules he has in order to get that authorization or not. In the case of the naming, the authority naming management system, it's rather similar. It's the same structure. We have the similar components, but instead of using naming authorities, we have authorization authorities that are the ones that are going to give the specific grant for the access to a specific resource using his ACLs. In this case, are rather similar to the one of the naming system. So here we can have two kinds of requesters, the one that access for authorization or attribute certificates in order to give access, for example, to certain resource. So then the resource is going to check just this authorization, obviously that is signed by the corresponding authority or the naming system, and in that way he will be able to give the access or not to the resource. Basically, DMS actually is implemented using this Intel CDSA implementation. It is also implemented using, in this case, Unix. And actually what we have is a complete set of tools that help all the, because one of the problems here with SPKI and all this structure is that there's complex the process of definition of the tags, definition of the different entities, the service access point, and so on. So we have defined several applications, we have implemented several applications in order to manage all these components in this case. Here we can see, just to show you a snapshot also of a specific, one of these specific tools, that is the one that is going to, is defining tags that characterize which are the resource and who can access to this resource, and which are the certificates that must present the user in order to access this resource, and so on. So just to conclude, what I can say basically is that we have, in this case, since a large process, we have a complete PKI, actually, that with a lot of different kind of services that is being able to be used for, obviously, for all the community in this case. We are testing it, as I said to you, in different projects, but obviously we are open to anyone who wants to test it and also give us idea about how to improve it or how we can use it in different environments. And over it, actually, we are working with two different contexts. In the extension, with the attributes and authorization using SPKI, basically this one, and the other one is the implementation of the policy management, basically in order to be able to define rules that make the behavior of certain kind of system, specifically in this case security device, be able to configure and make it their behavior dynamic in the sense of being able to change different specific conditions where, for example, a VPN can be created or can be eliminated and so on. Actually, these two services, specifically the one about the policy management, is being tested in the case of in the collaboration between Euro 6 and 6net, and it's been actively tested in this. I can say between the UCL and University of Murcia in order to check it's useful in different kind of contexts, because in the case of UCL they are particularly interesting, I think, in the active network. So the idea of having active components in the network that can have a dynamic behavior, not only for security but also for another kind of service, maybe in this case quality of service and so on. So this is all. Sorry for. Okay.
Thank you. We have time for one or two short questions. I will note that he has a wonderful body of work here.
Sorry.
Yes.
Yes, this sounds very, very good what you presented here. I'm imagining where could be the hook. But anyway, my question would be, you were talking about authorization and attribute certificates. Mm-hmm. What exactly is the difference between those two?
Well, okay, it's rather it's more semantic, I think, in some case, depending on who can answer it, but from my point of view, it's more a semantic distinction between one or the other. Basically, from a general point of view, they're basically the same in some sense. So it's no real difference between depending on the kind of resource you are granting the access. This I can say basically, but it's no more than this. Okay.
Okay. Thank you, Antonio. Oh, we have one more question?
Yeah.
Okay.
Yeah.
Did you have built application easy to use for example, personnel that, for example, must admin access to, for example, to machine for students in.
This is basically what, more or less, it is. This is the part where actually we are trying to finish. This is in the case of the credentials. I think it's more and the attribute certificates. We are implementing. We have actually several graphical tools in that sense in order to define which are the tags, where you, in an easy way, you define which are reserves, which are the grants that you are going to allow to this user, and so on. And you, with all these things, you define in some sense the tag that you are going. Basically, the tag is the indication about which are these components and which are the grants that you are going to define. And this is a store, so you can use it in any time in order to define, for example, for a specific group or users, the possibility of using the tag in order to allow its access or not, for example. So this is basically what we are working with now, actually in our system. In this case, in the case of the PKI, and also in the case of the, for example, for the policy management, also all the system is implemented in the web. So you can in an easy way and with a friendly user interface, you define the policy and you store it and you sign it and so on. And in the case of the PKI, also, we have all the different tools in order to facilitate either the inclusion of the certificate or just using the smart card in order to access your, for example, using getting the private key from the smart card and accessing to your certificate and recovery and so on. So in every case, we are always trying to do it in a user-friendly way because the main problem here is not to use it, but maybe to facilitate the use of the system in some case.
Okay, I'm sorry to interrupt, but we have to continue on with the next speaker.
Maybe we can...
yeah, Antonio, I'm sure will be around afterwards for further questions. Our next speaker is Eduardo Jacobs. Tried to pronounce it properly, sorry. He's from the University of the Basque Country in Spain, and he is going to be presenting on PKIX-based certification infrastructure implementation adapted to non-end entities. He is a lecturer in the Department of Electronics and Telecommunications at the university, and he teaches operating systems and mobile services and networks. His interests are wide and varied, but concentrating in distributed system security and has several R&D publicly funded projects, and currently involved in many internet security and PKI and intrusion detection systems. So, Eduardo, please.
Thank you. Good morning, ladies and gentlemen. I am Eduardo Jacob, and I am going to speak about a project we have developed some time ago. This is the summary of my speech. I will give a small introduction to the problem we are trying to solve. I present the main goals of our project, the system architecture. I explain also the way of operation in some cases to ease the understanding. And I finally explain the implementation details and the status of the project. I also try to explain the future work we are willing to do. Well, this project saw the light as a side effect of another project. We had a project for investigating the application services provider for a major ISP provider in the Basque Country. And once we began thinking in services, we found that although the PKI was was the natural way to give authentication services, we found that it was very difficult for users to properly understand certificates, to properly understand which was the meaning and how to use them. So as a side effect of this project, this development took place. Well, I think these days we have already heard much about certificates and PKIs, but anyway, we can see that the interaction with the certification system is normally through a web interface. That web interface is sometimes not very natural or not very easy to understand to non-technical persons. Also, this World Wide Web access somewhat gives some inflexibility, because if you request a new kind of certificate, you somewhat have to rethink and recode all the server and all the presentation pages, etc. There are also problems with interoperability in the event of you don't choose the extensions correctly or you employ them in a not good way. The result we have found is that nowadays we are using other protocols, other tools where PKI would better be suited. For example, we are using SSH, normally with user and password authentication. We are using PGIP. We are using some homemade SSL. Well, our proposed system is based on the work of the PKIX commands. It tries to automate a standard interface and has a specific application scope. Well, the main goals are this one. We were willing to design a full functional PKI system that would speed up procedures for requesting certificates, for getting them, and for installing them. We also think that we also thought that it would be very interesting to have a good scalability and interoperability. We would like to make it far more flexible in adding services, in adding new services, and to ease the access of the user to the certificates and the technology behind it. Well, that is a classic PKI architecture. In our case, we designed the RA. The RA is just a registration authority that can be in several names. Normally, it would be interesting perhaps to have them geographically situated near of the end users because of the registration procedure. We also have a CA. The CA is, in this case, we will see it later, but we blindly assign a certificate request. We don't have a manual step. That's the particularity of our project. Also, we have a repository where we put all the CRLs and all the certificates. And finally, we have the end entity. The end entity, in our case, tries to be non-personal. What does this mean? It does mean that we don't want the user to interact with the system. We only want the tool to interact with the system. That means we will see that at least we only ask for a user ID, for a password, to put the whole system in operation. The tasks are very classic. In the RA, we will register the users. We'll authenticate them. I will forward the request to the CA. In the CA, we will basically register the RAs for recognizing them as valid RAs. And we'll make operation with thirds. Well, the first step in our system is to register with the RA. For this task, the client goes to the RA operator who interacts with an RA server. The protocol we have designed uses a protocol based on command answers over an encrypted and SSL link. Normally, we will ask for a kind of certificate that will somewhat prepared in a database. So we will have several types of certificates that will have several extensions that will have, in the event of localization, several fields pre-recorded. So we tried not to ask things that are not necessary to user. So in a certain way, when we have a necessity to fill a field, we'll ask the RA operator to fill it. Some others will not be necessary. And finally, we will finish the process with a pre-request, which is completely filled with good values. And at this point, the system will send an ID and a password to the RA operator. This ID and password should be given to the new user by means of an out-of-band channel, because, well, that is very normal. Well, now here we can see debugging log of the application, where we see the RA asks for some components of the certificate, and on the other side we could see that the RA operator sets the correct value. Well, you can see that we ask several information, and at last we have a commit. You can see also that it is a protocol of commands and answers. Well, what does now the user of the application? The application itself has a PKIX support by means of an adaptation layer and a cryptographic library. The general functions we have defined are the following ones. We have operation with certificates, checking certificates, secure connection management, and downloading of certificates. In this case, when we start the tool for the first time, we will be asked for our user ID and our password. And the application will generate a CMP request. This CMP request could be as we could think of it as a fake CMP request, because we only will use from it the ID and the password. We will send the CMP request to the registration authority, and once in the registration authority, the RA will only take the ID and the password, will check if it is a valid couple of them, and now he will fail another CMP request. He will take, based on the ID, the pre-recorded request. He will add the public key that was sent in the original CMP request, and will sign itself before sending to the CA. That's one of perhaps the difference of the good things our protocol, our setup, is that this is totally automated. I mean that we are using CMP in a different way that it was first thought of. Well, when it arrives to the CA, it is very easy to understand. First, the CA will check if the request is coming from a certified RA. It will sign the certificate. That is very important to see that now this process is automatically executed. We don't have a manual operation. This seems to be perhaps a security problem, but we don't think it is difficult. I think that it is the way to be able to use anytime, anywhere certificate this way. Well, once we have created the certificate, we will store in a database, we will send back to the RA, and we will store in the repository, the DAP repository. Well, the implementation. At this time, we have implemented it over Linux. Daemons created in C language and using POSIX threads. The database we have used is MySQL, OpenLDAP for the directory, and we have used the cryptographic library. That library, we will see a bit later, has several advantages and some disadvantages. One of them perhaps is it is the non-free library. Well, if someday this project see the the light as a commercial product, perhaps it will be a problem, but nowadays it is not. Well, I try to explain a little bit how is the RA implemented. We have several interfaces from the operator, the administrator. These interfaces are based on SSL, and the administrator duties are only for maintaining the application. It has not, it doesn't have security tasks in the administration. It's not a security position. There is also a PKIX access module for interacting through CMP protocol. And we have two databases, one of them where we have the pre-recorded request, and also with another one where we have the administration information, for example, authentication, RAs, public keys of RAs, etc., that are needed to fully deploy. We also have a module for signing the request before sending them to the CA. And I haven't told it before, but this RA is also working as OSCP responder. That gives the system fairly good scalability, because we can employ this facility as a cache for OSCP protocol. So if a client wants to check the validity of certificate, he can ask directly to the RA, which is geographically near from him, and perhaps also in time near of him. And if this RA doesn't have the status of that certificate, we'll be able to ask for the CA, and after that storing them in a cache for a later consult. Well, there are two pools of threads. One of them is only one is only for OSCP processing, and the other one is for CMP processing. We employ pre-started threads for giving good performance to the system. Well, I think this has been done. Well, one interesting feature we added to our server, it was the debug log. This debug log was done through means of another thread, and has the possibility to send the information directly to a file, directly to the console, or even through an encrypted SSL connection, making it very easy for the administrator of the CA and the RA to debug. That would be a sample of debug information. The CA is very similar in implementation to the RA because of precisely the decision we took for this. Well, basically the certificator, I want to say again here that we automatically sign the request. We rely completely in the RA decisions. Well, the status of the project at this time, well, there are about 10,000 C code lines coded majorly by one person, by Fidel, that is here. At the moment, we have the functional system integrating the RA and the CA in one system. We have also the RA server, the operator, and administrator clients, and Java frontends, because we have seen that we are working with protocol based on command and responses, and we have seen it, but over that we can build any interface, and we have built Java interfaces for it. We are using the Cryptly library. The Cryptly library has several advantages for us. One of them is the ease of use due to standardized interfaces. It has a very good user manual, about 300 pages with many examples, and it is rather easy to get results in a very short period. Also, he had directly many operations implemented that are needed in certificate programming. The disadvantages are perhaps coming from the advantages also. It's a very high-level interface. That means that if you want to change the working of some small function, it's very difficult to go down to the code to find where really it is changed. This is really this is a feature because he has implemented the security kernel concept, the CB concepts, in when you ask something to a module and the module gives the permission you or not. But it has been difficult for us. We have found some problems in the network support, perhaps in the, I remember in the support of blocking recepts and unblocking recepts that gave us a bad performance. And we have also found some quirks in the MySQL support. The future work is divided into kind of things. The things that we would like to do and the things that we would like to happen. The thing we like to do is perhaps adapt this technology to smart cards, to personal security environments based on hardware, which would give us some points interesting. Perhaps integration with another certification system like PGP. The inclusion perhaps of attribute certificates. And what will we be doing? We will be willing to have a real application to try this. We have not been very successful in our environment to persuade people in using this kind of technologies. Even if it is not related, in the Basque country there is not still a public key authority established. And even it has nothing to see with this kind of use of the PKIs. Once people see the word, they are thinking in waiting for seeing which will be the definite solution coming from the government. So we have found some of these problems. If we would have a real application, perhaps we see that it would be necessary to develop Windows-based clients and libraries. Really, at this moment, we are more in the feeling that we have a good hammer and we are still looking for knives. So, well, if you have any questions, I will try to answer them.
Any questions? Oh, Peter?
You were talking about that the RA is also fully automated. Does this mean that there's nobody who's going to check the identity by looking at a passport or something like that?
No, the RA is not fully automatic. You have an operator that interacts with the end client. That could be a security officer in an enterprise. But no, you have to pre-record, and that data must be authenticated and must be clearly checked.
Okay, then it was a misunderstanding.
Perhaps it's my English. So.
In the last line on your slide, where you are talking about a real application, and you said you are looking for a real application. My question is, do you have any idea, or is there any possibility to use this new set of functionality you are developing with traditional applications? Because from my point of view, this is actually where we could make a difference right now, if we would be able to sort of to make use of those new facilities for the regular applications that are in use these days, instead of looking for a new application which might come in 1 or 2 years' time.
Well, we have, to tell you the truth, we have developed a small trial software in the orbit of this ISP project. We were thinking of developing a service for signing and time stampings. I don't know which is the word in English. The minute of meetings. For example, once you have a meeting, you prepare a minute of the session and an application to sign and timestamp that meaning for everything, for validating this minute of the session. And we prepare a small application for that. But well, it's done.
Okay, Eduardo, thank you very much.
Thank you.
Our next speaker is Dr. Peter Alterman. He's with the U.S. Federal PKI Steering Committee from the United States, and he is the Director of Operations for the Office of Extramural Research at the National Institutes of Health, and is Senior Advisor to the Chair of the Federal PKI Steering Committee. He's been actively involved in Internet technology since serving on the Federal Research Internet Coordinating Committee in 1989, and most recently been spending most of his time on an NIH EDUCAUSE PKI interoperability project, and has won the Management and Leadership Best Practice Award for the Computer Security and Information Assurance Conference and an eGov Pioneer Award. And I personally have had the pleasure of working with Peter over the last couple of years on this project. So Peter, the floor is yours.
Well, thank you. I'm now looking for my presentation. Well, good morning. I know that I'm what's standing between you and lunch. And I will try to be as cognizant of that fact as I can be. Why don't you get talking? All right. Let me start out by saying that almost everywhere I go, I have to counter this accusation that PKI either was stillborn or had a very brief life and died while no one was watching. This is very distressing since I've been actively working at pretty much nothing but PKI for the last 4 years. And in particular, what I've been working at, I'm going to stay away from this side of the stage. What I've been working at is the Federal Bridge Certificate Authority. Now, let me tell you what a PKI bridge is, briefly. A PKI bridge is a router of trust. It is a combination of policies, software, and hardware that allow unique trust domains to interoperate. And what Michael mentioned before is as our project, Keith Hazelton from University of Wisconsin-Madison was also part of this project. We were able to use the Federal Bridge CA prototype, a lab prototype, running Entrust, Microsoft.NET CA Beta 3, and RSA CA, all interoperating inside the membrane, to create a trust path to a higher education bridge, which cross-certified with 3 university CAs. Let me see if I can get it to you. Let me get out of this and go to the one I want to show you. I think this is what I want to show you. Yeah, this is what I want to show you. All right? This was our concept of operations. We had 3 universities, University of Alabama at Birmingham, University of Wisconsin-Madison, and Dartmouth College. They all downloaded an electronic grant application form, filled them out, signed them with their own certificates issued by their own universities. These are in some cases operational PKIs, and in one or two cases they're being set up. At the point where I received their signed grant applications at my pathetic little desk in my pathetic little government office, I was able to validate the certificates from an Entrust CA, a Netscape iPlanet CA, and DST Trust ID CA using RSA technology. 3 different products, 3 different unique PKI domains. The bridge's let me do that. Because what my software in the middle, validation software which we developed and which is open source and I'll tell you about, looked at the certificate, said, well, that doesn't belong to the NIH PKI, National Institutes of Health, where I get my paycheck. And went to the Federal Bridge, said, well, it's not one of ours, let's check the Federal Bridge. And the Federal Bridge looked at it and said, well, that's not one of ours, it must be the Higher Ed Bridge. And by gum, the Higher Ed Bridge was able to say, University of Alabama, Birmingham. And my query was able to hit the CRL at the University of Alabama, Birmingham, and return a yes or no to my desktop, which told me the certs were either good or bad. Now, this is a real app. Well, we didn't actually do it live because we had no policies, but this is a real application, an electronic grant. Now, I don't know anybody in this room who's not interested in getting a grant. So I expect everyone in this room really thinks this is a cool idea. And I know that there are at least 2 universities in this room, 3, that have PKIs up and that are issuing certificates to faculty, staff, and students for a number of things. For the library, for access to rooms, for distance learning, for any broad number of administrative tasks. The university does not want to have 25, 35, or 50 certificates to do business with 15, 20, 30, 40, or 60 government agencies. Or partner universities in research projects, or partner universities in classrooms, or libraries. The whole point of using a bridge is so that you can use and rely on someone else's certificate, and you don't have to issue certificates to people you want to do business with electronically. All in all, a bridge is a great idea. All in all, the whole concept of bridges interoperating is what will make a global PKI happen in your lifetime. Hell, it'll happen in my career lifetime. And I'm looking to retire in about 9 years. Now, why am I so confident about that? Well, I have a federal bridge that's operational. I have the National Aeronautics and Space Administration cross-certified with it. I have the Department of Defense cross-certified with it. I have the National Finance Center of the Department of Agriculture, which processes most of our checks, paychecks, cross-certified with it. I have the U.S. Department of Treasury coming in. I have the Department of Labor coming in. I have the Department of Justice coming in. I have the federal government cross-certifying with the federal bridge. I have the federal bridge cross-certifying with the higher ed bridge. I got 3 universities in now. I'm going to get the University of Texas system in. I'm going to get the University of California system in. I've been talking to the grid folks. They're real interested in this concept too. Bridges interoperating with each other is the way that PKIs go global. And now it may not be the way PKIs go global in 10 years, but you can't do what lots of people think. You can't start here and make a leap to that door without making a few steps in between. And if by chance you change shoes from my good old Florsheims to Nikes, by the time you get to that door, well, hey, that's just the way your feet do it. And just because I'm not wearing Nikes now doesn't mean I can't get to the door. So, my partner in crime, Judy Spencer, who's the chair of the Federal PKI Steering Committee, is meeting next week with Boeing Aerospace to talk about setting up an aerospace industry bridge and cross-certifying with the federal PKI bridge. My friends in Taiwan are having us out in November to talk about building an Asian business PKI and cross-certifying with the federal bridge. We've met with the Brits. The Canadians want to come in. the state of Illinois, the state of New Jersey, the state of Washington, the state of Texas are busy putting together plans to put up a state government PKI bridge and cross-certify with the federal bridge. And oh, if that's a little slow, they're just going to cross-certify with the Fed bridge directly. This is what's... I had to give a presentation to the Federal PKI Policy Authority. It's just another bunch of bureaucrats that runs the bridge. And my presentation was supposed to be on design considerations for the bridge infrastructure. Well, what that was the problem was, do we have one point-to-point-to-point connections? Or do we have a full mesh? Do we have a hierarchy? What is the topology of the bridge-to-bridge infrastructure? I find it very interesting that at this point, when PKI has been pronounced dead, we've got a groundswell of implementation, a groundswell of PKIs being put up and connected together, and I'm being challenged to come up with some preliminary architectural design for a multi-bridge infrastructure. This does not sound like death to me, ladies and gentlemen. This sounds like birth big time. And if anybody wants to know about PKI survivability, there is nothing inherently dangerous about consolidation of a business sector. There have been quite a bit of press worrying about who's going to survive in this space and who's going under, and is VeriSign laying off people, and is Entrust going to survive, blah, blah, blah. Fact of the matter is that Microsoft has come into this space big time with their .NET CA. I've seen it. I've seen the future. It's Active Directory working with Microsoft .NET CA. Why do I say that? Not because it's good, not because I like it, but because history tells me that whenever Microsoft poaches on a space, the industry consolidates. And the industry is consolidating. Identrust bought Digital Signature Trust. So now we have 2 instead of 3 managed service providers. I don't think that's a bad thing. Baltimore is coming back into business. Silink is gone, but that's all right. Consolidation means a better survivability for the industry, not a collapse of the industry. So I think that what we're seeing in a consolidation of PKI vendors is a sign of good health. Now, let me talk about this little honey again. I told you that we had done this infrastructure. What I find really exciting about bridges is that bridges solve a lot of problems. The whole point of PKI, signature-based, not encryption-based PKI. I don't want to talk about encryption-based PKI because that's not where I work. Okay? That doesn't mean it's not important. It just means that's not where I work. Where I work is real applications to be signed. Right now, excuse me. You know, it's the microphone that ate me. Right now, we have a lot of applications in the United States government that require electronic signature. The government has given us 24 applications that are supposed to be up and running electronically by September 30th, 2003. And we have to have an awful lot of applications PKI enabled, electronic signature enabled. I always get, I'm biased. I think electronic signature is PKI, but it's not. We have to have a lot of these, we have to have all of these 24, plus a whole lot others by the middle of October 2003. Well, what we have going on is an e-authentication process in the federal government of the U.S. And the e-authentication process is a cross-cutting implementation, a cross-cutting program that's providing authentication services to these 24 applications. And the 24 applications run the gamut from electronic grants, something that's near and dear to my heart, to online reservations for campsites at national parks. You know, you go on the web and you click on Yosemite Park and you pay $25 or $30 for a registration using a credit card, using an SSL connection, and you can get your reservation. So it goes from the sublime to the ridiculous, and frankly, the ridiculous is the grant part, and the national park thing is the sublime. Anyway, there are lots of ways of skinning that. We have statutory requirements that are forcing us to PKI. That's why these government agencies are PKI enabling their organizations. That's why they're issuing certs. Now, these government agencies don't want to issue credentials to their business partners. The United States government does not want to issue 275 million user ID password pairs or 275 million digital certificates. But we have to have a way of identifying who we're doing business with over the internet, and we have to do it in a way where we have some reasonable level of confidence that the person who's speaking to me is the person who's speaking to me, and not, you know, Uncle Jed who lives in the basement. Well, for low-risk items, you can use a user ID password. But when it comes down to really important stuff, like you're transferring money, or you're transferring data about an individual's medical records, or you're prescribing a controlled substance to a pharmacist 3,000 miles away, you've got to be sure that the person who presents his credentials is actually the person who owns that credential. And the only way to do that we know these days with any level of reliability is PKI. And so the government is preparing, my Department of Health and Human Services, my mothership, is preparing to put up its own PKI right now. I'm on the project team. And I know that we've just let a contract for $400 and some odd thousand. You know, I'd like to have that myself. Well, we've issued a contract for over $400,000 to design it. But it's not just designing the PKI with the RA and the CA and all of that hoo-ha. It's designing a certificate acceptance policy as well. How we are going to accept other issued credentials. We believe that we can accept those using the bridge mesh. And we believe it enough so that we think there'll be enough of a bridge infrastructure, a PKI bridge infrastructure in this time, so that in 15 months we'll be able to start relying on certificates issued by our citizens and business partners and use affixed to business applications that we are going to generate. So that if you want to reserve a campsite at Yosemite Park, you can go on to the National Parks of America website, you can fill out the application, you can sign it with a digital certificate that you issue, or that you bought from a managed service provider, or you got some other way. And we will have a method of validating that probably runs through at least one and probably 2 or 3 bridges. We believe that enough that we're putting up a lot of money. Our request for the year 2003 is over $6 million. I'd like to have that amount too. Well, anyway, I start to think about all the money I'm throwing at PKI. I think about hiring painters so I don't have to do my daughter's room myself. Anyway, I'm sorry, I drift. What we are having happen, and as a direct result of this pilot, is that we are now basing real-life design decisions on the presence and the operability of bridges. And we now have not only an issuing strategy, we have a relying strategy. And the relying strategy requires that we believe that certificates are going to be issued in a lot of places by a lot of certificate authorities. And we're prepared to figure out how to trust them. I also sit on the certificate policy working group of the Federal PKI Policy Authority, and what we do is we map CPs. And I've mapped 3 CPs in the last 6 weeks. And it's an ordeal, and I'd rather leave it to the lawyers, but I can't. So I know that this can be done, and I'm telling you, I'm from the U.S. government. Trust me. Well, all right. You can map a CP, and you can have trust. You can trust another PKI, and you can actually use another PKI certificates. You can get there using a bridge infrastructure, and you can trust their policies by mapping theirs to yours. And all of these things are happening, and they're happening very fast. And I guarantee in 3 years it's going to look a whole lot different than it does now. Right now we have pockets of excellence and innovation coming up. And we're going to have in 3 years broad swaths of implementation. That's what I see. And that's what I see because that's where I'm going. And that's where I work every day. Okay, I think I better stop. And we got 5 minutes for questions or a mad dash to the lunchroom. Take your choice. Yes, sir.
Just one question. Who does store the private key of the bridge? So who is the person that can say, yes, you can be part of the bridge, or no, you can be part of the bridge? There will be always someone above all others, I think, or no?
No, the bridge is not a hierarchical route.
Yes, but there is someone who can say, yes, you can be part, because I have read your CPA and CPS, and so you can apply to the bridge, and no, you can't, because you...
I've mentioned the Federal PKI Policy Authority. The Federal PKI Policy Authority is made up of representatives of federal agencies who are cross-certified with the Federal Bridge, or, you know, the starter team, you know, like you have starter for bread, you know, yeast and stuff. We have 6 agencies that are starters. Those 6 agencies vote on whether or not your CP and your practices statement and your audit report are adequate to join. So it's a membership club. And who votes on it are policy people.
So it's a democratical way. It's to say the people inside the bridge can accept the people outside the bridge.
That's right. That's
and
exactly the way it is.
Okay.
Yes. And we've accepted 3 new ones in the last 6 weeks. And we're going for 3 or 4 or 5 more. And we're not going to just federal agencies.
And if I may, so for the higher ed bridge, there will be a policy management authority for that as well, to deal with cross-certification and policy mapping within the higher ed community in the United States. And it will be that authority that works with the Federal PKI Policy Authority to develop that relationship between the higher ed bridge and the federal bridge.
And we're... Yes, sir.
Hello. You were talking about the the trusting of the digital certificates. I was just wondering what you thought about the media storage of today. Is that sufficient enough in terms of floppy disks and the storage of digital certificates to prevent the compromise?
Well, you know, implementation is the dirty little secret of all of this. There are ways of doing it right, and they're not the easiest ways, and they're certainly not the cheapest ways. What we call a medium-level certificate can be stored in software on your hard disk or exported to a floppy disk and carried around. And frankly, those certificates are controlled by a password. So you know, it's the yellow sticky disease all over again. But a high-level certificate that's stored on a smart token of some sort, a hardware token of some sort, is much more secure. And I have seen, I've been told by people lately that there's a lot more hardware tokens coming. You know, they've been saying that for years, but you know, people are talking about Social Security issuing 90,000 hardware tokens to its employees, and AOL is going to issue PKI certificates to a lot of its users. So it's just a matter of implementation and need. I would never have a digitally signed contract for a federal contract, you know, in the millions of dollars. That's not hardware. Not hard token based, because that way, you know, lies irresponsibility.
Right.
Yeah. Thanks. Yes, sir.
The classic criticism of classic X509, which is what you are building here, I guess, is that the scope of X509 identity certificates is to deliver identity strings to applications, and then you're left with the problem of what applications do with those identity strings.
Right.
So does all the policy mapping across all the entities that are connected by all these bridges impose naming requirements on all the agencies that are participating? And
I'm going to let Michael answer that one.
If not, then how can I, as an agency, possibly accept one of these certificates when the student organization at the University of Washington that's issuing certificates that's certified by University of Washington, and University of Washington is certified by the Washington State PKI, right, and the Washington State PKI is certified by the National State PKI across the bridge, and that student organization issues a certificate to Peter Alterman, and that name Peter Alterman arrives at the IRS and is doing some operation. You know, how can they possibly accept that?
How could they possibly accept that, Michael?
You want me to answer? Subject names are part of the whole naming constraints problem, and when you issue cross certificates, part of the cross certificate is an enumeration of namespaces from what would be in a subject name. So in the case of Georgetown University, that might be DC equals Georgetown, comma DC equals EDU. For University of Washington, maybe O equals University of Washington, C equals US. So you can do inclusion as well as exclusion. And it's through that policy aspect and implementing name constraints that would prevent that student organization from issuing an NIH, what appears to be Peter Alterman in the NIH namespace.
Okay, so correct operation of names constraints across all participating parties is a requirement to make this stuff work.
Assuming that everybody is bridge aware, which is kind of a requirement to operate in this environment, yes.
And it's sort of like that's going to happen because if you include yourself in, you know that that's a requirement, and that's monitored by the bridge policy authority and the operational authority.
Question over here.
Yes, sir.
Yeah, I'd like to come back to your description about the open issue of logical relationship amongst the set of bridges. And I think you did provide the answer to my question somewhere in the second half of a sentence. But I'd like to ask the question here in the open once again. Do you have any expectation or any proposal what the logical relationship, the topology, should look like or would look like amongst the bridges within sort of a 12-month time frame?
Well, yes, I do. I have my biases. You can't do it point to point to point because there are too many single points of failure and there's a latency problems. You can't do the big kahuna approach where everybody connects to one hub because who are you going to trust to be that big kahuna? And you don't want to do hierarchies of hierarchies because you got nobody to manage the hierarchies and everybody wants to be the top dog and no one wants to be the little dog. So what's going to happen, I believe, is that we're going to have a recirculation of what happened with the internet nodes, and that there's going to be a full mesh. Every bridge is going to be connected to every other bridge, mostly. Now, there can be some logical, topological problems in that. You could get endless loops, for example. You could get disparate trust levels that clash. But I think eventually and inevitably we're going to have a full mesh. And why I think that that's probably not as bad as having a full mesh, you know, of every PKI having 1,000 trust lists, 1,000 other PKIs in its trust list, is because there's going to be a finite small number of bridges, because bridges are by definition aggregative rather than dispersive.
Okay, because sort of my background is more in the PGP area, and I'm pretty illiterate when it comes to PKI. And
anarchist.
Yeah, but my feeling is that we seem to somehow a little bit to converge with sort of the PKI camp borrowing some ideas from the Web of Trust thing in PGP, and on the other way around, the PGP people finding out the hard way that you need some sort of logical structure to make it scale.
Yeah. Oh, that's an interesting perspective. Yes, sir.
You mentioned Microsoft, and we're starting to see a lot more certificate support in Windows XP and Windows 2000. And there's also this root certification program that they're operating. And I just wonder, are they aware or are they tuned into the activity in the Federal Bridge, or are they going off in a different direction?
It's always interesting to talk about Microsoft and not get paid for it. So, you know, since money is not falling from the sky, let me be brief. Microsoft has, I've worked closely with Microsoft. Their .NET CA, the one that's coming in next quarter, they claim, has been tested by the Federal Bridge and has passed the tests and will be, as soon as it's shrink wrapped, it will be in the Federal Bridge. We've worked closely with them. They're very interested. They're very supportive. Now, having said that, let me also say that Microsoft is busy out there trying to propagate the passport model. Right? And the passport model is inimical or diametrically opposed to the high reliability PKI model of their .NET CA. So as usual, Microsoft is trying to have it both ways. And we're finding clashes of those two approaches affecting us in the government, where some high-level policymakers say we should go with the quick and dirty, and we're saying we need to go with the trustworthy. So it's kind of, Microsoft is really positive, and Microsoft's a real dog again. I'm in a situation personally where I now am starting to proliferate certs. I have a Microsoft cert from my Exchange 5.5 server that's being run out of my infrastructure. I have a single sign-on .NET cert that I use for the Federal Bridge as a demonstration. I have a Trust ID cert that was issued by DST to me that I use on the everyday. That's a medium-level cert. And I'm expecting to get a high-level cert for something I'm doing with the DoD PKI bridge. So I would like to have one and not, and right now I got 4.
Okay. Well, as you can see, Peter Alterman can do an awful lot with just one slide. I'd like to thank Peter for his presentation. Peter will be available at the Meet the Speakers during lunch, which we are, of course, late for, and hope to see you all at 2 o'clock for the continuation of the middleware activities.
Thank you very much.
Thank you, sir.
Good to see you.